So hello, today I'd like to present my research on food rescue. So first, a very brief introduction of the context of the problem. We're looking at the problem of food waste, which is a pretty serious problem in the United States. Every year we can see that 62.5 million of tons of food is wasted, and the majority of them goes to landfill directly, while the rest remains unharvested. And on the other hand, however, 13% of the US population is still feeling food insecure, meaning that they're in fear of not having enough food or will not have enough food in the future. So it's by estimation that it wouldn't even take 1/3 of the food that we throw out to feed this population. Therefore, in order to solve this issue, the idea of food rescue emerges in major cities in the United States. So the idea of food rescue involves taking food donations from stores, restaurants, and retailers and then transport them to nonprofit organization or government to redistribute the food among those who need them. So the food rescue platforms have happened in San Francisco and other major cities, but we're closely looking at the case of 412 Food Rescue, which is based in Pittsburgh, Pennsylvania. So for 412 Food Rescue in particular, there's three ways that they transport the food donations. First is through trucks that are owned by 412 Food Rescue, and then they also have collaboration with volunteers on weekly pre-scheduled rescues. However, the majority of the rescues are claimed on the app by volunteers. So once they have the rescue, they'll publish it on their mobile app called Food Rescue Hero, and as volunteers, you can claim the rescue on the app, and then do the rescue yourself. For these kind of rescue, however, it has an 8% miss rate, so which is pretty high. So here we'd like to look at what Food 123 Food Rescue have achieved. So ever since its start in March 2015, it has rescued 5 million pounds of food. And when we turn that into money, that's $14 million in retail value. It has 3,000 registered volunteers and 35,000 rescues. So this is the process of a food rescue that we have done. So basically, first you look at the rescue on the mobile app and check if you want to do the rescue. If you want to do it, you can claim the rescue on the app, and then what you do next is to go to the donor at the pickup window that's specified, and then you get the food, and then you travel to the recipient and carry the food, and then it'll have the delivery instructions on the app, and you can just deliver the food. So we'd like to investigate into what caused the rescue to be missed. Based on the data analysis on the left, we can see that hotter and colder months such as January and February have higher miss rate. And then we'd like to investigate into what is the specific reason for a rescue to be missed. So we can see that no donation from the donor is the major reason, and the secondary reason is that there's no one who claimed the rescue. And then we'd like to look at the miss rate based on donor locations. So we use the zip code location as donor locations. We can see that some regions have really high miss rate, while other regions have only 0% of miss rate. So there's a very big difference. So with the data analysis that we have done, we'd like to see how can we improve the success rate and the fairness. So when a new donation comes in, we want to build a machine learning model that can predict whether a rescue will be success or not between the donation and each recipient. So if this rescue is likely to be missed by other recipients, we inform the human dispatcher to take more actions because there's not really anything that we could do on our part. However, if the machine learning model predicts that the rescue might be successful with some recipients, then we model the problem as an online bipartite matching problem, and then match the donation to the recipient based on how much food it has received in the past and what number of rescues has it received. So this is a brief introduction of the machine learning model. The features that we're using is the weather and also the zip code location, which are the two things that turned out to be correlated with whether a rescue will be missed based on the previous data analysis. We could see that the data set we're using is pretty imbalanced because, as mentioned previously, only 8% of the rescues are missed. And since we're using the operational data set that's provided by 412 Food Rescue, which means that 8% of the data point is missed, whereas 92% of the data point is not missed. So to solve this issue, we propose using bagging ensemble as iVotes. And more specifically, one of the tricks that we're using is that we sample with replacement to train different classifiers for the ensemble. And the result is shown in the table, where we can see that the bagging ensemble with 3 support vector machines has a 90% accuracy and almost 90% recall, and it has better F1 score than any other algorithms. So with the machine learning model, we built our matching algorithm. So we modeled the problem as an online bipartite matching, where the recipients are known where the recipients are the nodes that are known, and the donations that are the nodes that got revealed to us one by one in an online fashion. So whenever a new donation arrives, we use the machine learning model to determine if there exists an edge between the donation and each recipient. And then, after we have modeled the problem as a matching problem, we use the 2 fairness criteria to determine which recipient this donation goes to. The 2 fairness criteria is first the quantity of the food. So we want to make sure that each recipient receives the same amount of food. And then the second is the number of rescues, which means that because the weight of the amount of food in each donation may vary a lot. So if a recipient has received a very large donation at some point, then it's very likely that it will not receive any donations for a very long period of time, which is something that we don't want there to happen. So therefore, what we did is we have this algorithm that maximize the minimum amount of food that's received by each recipient. And then after each recipient has received more than a certain amount of food, we refresh the algorithm entirely. So we start from the 0 again. So this is the evaluation of our algorithm, where C is the refresh constant, meaning after each recipient has gotten C pounds of food, we refresh the algorithm. So as we can see here, the first table shows how our algorithm performs compared with the current practice. We can see that for the current practice, the number of donations vary from 0 to 420, which is really large number, whereas for our current algorithm, the number of donation is ranging in a more reasonable range. And on the second table, it's the similar case, except for the case that we're measuring the quantity of allocation. And then we turn the performance of our algorithm and compare with current practice in graphs. So the yellow line here represents the current practice, where we can easily identify the 20/80 problem, where top 20% of the recipients gets 80% of the donations. So this is very unfair. The other 3 lines, the gray, the orange, and the blue lines are our current practice with different parameters. We can see that our current algorithm is achieving a lot more fairness than the current practice. As for the future directions of our project, so currently we're trying to improve the message notification scheme. So currently, what 412 Food Rescue is doing with notification is that whenever a rescue is published on the app, it'll notify volunteers within 5 miles and then wait for 15 minutes. If no one claimed within the 15 minutes, it will push notification to all volunteers and wait till the last hour of the pickup window. And if after that still no one claims the rescue, then the dispatcher will call active volunteers to see if they can help. The limitation of the current scheme is that there's too many notifications then, because there's several thousand volunteers at the 412 Food Rescue. So and there's a lot of rescues every day. So if it's the case that the volunteer receives too many notifications, then it's easily likely that he'll get bored and maybe uninstall the app. Therefore, what we want to do is to design a notification scheme that we don't contact or we don't push notification to too many people, while ensuring that the rescue can be claimed by whoever can claim it. Alright, so that's basically about the presentation, and we'd like to get your questions. Thank you.